All right, the first family we're going to learn about today is the alkenes. A lot of the same stuff we learned from the alkanes is going to apply to the alkenes as well. All the branching rules stay basically the same. What does change is how we find and number the parent, and that's going to be an important distinction that we change moving forward in how we find and number the parent molecules now that we're adding in these new families. So let's start off with just what an alkene is. And an alkene has a carbon-carbon double bond, and that's what makes it a part of this family. This is what we call a functional group. It's something that gives that molecule certain properties. So all of the alkanes act somewhat similarly. All of the alkenes, anything that has a double bond between two carbon atoms, they also act in a different way. And then we're going to add some more families as we go along. Now, the important distinction here is this double bond has to be between two carbon atoms. Later on, we're going to have some molecules that have double bonds between carbon and oxygen, and that's a different thing. It doesn't count as an alkene. That's a different family. So these are also considered unsaturated molecules, and the reason is because of the general formula. So these are CnH2n. The alkanes, remember, were 2n plus 2, right? Double the amount of carbons and add 2 to find the hydrogens. These are only double, and the reason being, if you remember that in a covalent bond, there is a pair of shared electrons that forms that covalent bond. So in order to form the double bond, we had to take electrons away from somewhere else. And we had to basically lose a hydrogen from each of these carbon atoms in order to have the electrons we needed to form the double bond. So we're going to have less hydrogens, but we've formed a double bond. And because of that, we call it unsaturated, or it's not filled with hydrogen or filled with all the bonding that's possible because of, at least to separate atoms, because of this double bond that's there. Okay? Now, the next thing that changes is how we identify and how we number that parent. So if we take a look here, on your notes, there is the next part there. The parent is the longest carbon chain, that's the same as it was in the alkanes, that contains the functional group, or in this case, the double bond is the functional group. So we're just going to write this in here. And you have a little box there. I'm just summarizing this. This is for numbering the parent. That's a weird looking T. How to number the parent molecule. Once you've found that longest chain, how do you decide if that side's carbon 1 or that side's carbon 1? And the way you do that yesterday is I said that we always give the branches the lowest number. And that's true, but there is actually one priority or one rule that's higher than that one, something that's more important than the branches, and that's the functional group. So if you have a functional group, in this case an alkene, that double bond, the double bond is more important than all of the branches. So even if you had 15 branches on this side and a double bond over here, you would number from that side because the double bond is more important than any branching that's going on. Now, there is a last resort too. If the functional group didn't help us, and if the branches didn't help us, like it was in one of the homework problems where if you numbered this way, you got a 3-4, and if you numbered this way, you got a 3-4. So the branching didn't help me because it was the same numbers either way. The last resort is alphabetical. So if you had a ethyl group and a methyl group, you would put the ethyl group, give it the lowest number, and then the methyl just because of their alphabetical order. But we really only use that as a very, very last resort. If functional group didn't help me, if branch number didn't help me, then I would use that alphabetical. All right. So that is how to number the parents. So when we do this, we're still going to find our longest carbon chain. We're now going to change the ending of the parent from alkane, from the alkanes to -ene, because it's an alkene. And in some cases, we may have to provide a number to tell me where in the molecule that double bond is. And I'll show you in the examples what that means. Everything else, like the branching, is going to still apply. So here's our first example. I have a 2-carbon parent that has a double bond in between them. 2 carbons means I'm going to start the name with eth, and because it has a double bond, it's going to end in -ene. So this is ethene. I don't have to number where the double bond is because there's only one place a carbon-carbon double bond could go in this molecule. So I don't have to call this eth1-ene, although that wouldn't be incorrect. It's just unnecessary. So this would just be ethene. Okay, let's try the next one. This molecule is a 3-carbon parent, so it is a prop. It also contains a double bond between carbons, so it's a prop-ene. And I don't have to number this one either, although prop-1-ene wouldn't be incorrect. The reason being is if I move that double bond from the left side of the molecule to the right, I would just number the molecule from the right rather than the left. So either way, that double bond is going to be on carbon 1. Since it doesn't change anything, it's unnecessary, so I could just call this prop-ene. Okay, now we have 4. So I have a 4-carbon molecule, which makes this a bute. And because there are multiple places this could be, I have to number it, because it could be on the left, or it could be in the middle. Now, if it's on the left or the far right over here, it's going to be a 1-ene, either way. But because that middle spot exists, it could be a 2-ene. So this is a bute-1-ene. Remember that dashes always go anytime you move from words to numbers. So I have to have these 2 dashes right here as I go from words to numbers and then from numbers back to words. So this is a bute-1-ene, which should make the next example fairly easy for you to do. And that would be a bute. Oh, hold on. Whoa, I'm trying to draw here. Go back. Let me just get back to where I was. Give me a second. Okay, and we're back. So this would just be a bute-2-ene. Right? Hopefully that makes sense. Now these first ones have just been very straightforward. Can you name just the parent? Now let's look at what happens when we have an alkene parent with some branching. All right, so here we go with a 4-carbon parent and a branch. Now, because the functional group is most important, I'm going to number this carbon 1, 2, 3, and 4. So that branch, that single carbon branch, is on carbon 3. So this is a 3-methyl. Remember that YL ending tells me that that's a branch. And then my parent is a 4-carbon chain, which is a bute-1-ene. So this is a 3-methyl bute-1-ene. So now we're just combining those rules. Okay. One last example. Our longest carbon chain that contains the functional group is right there. So I have a 6-carbon chain, and I could go ahead and number this as well. That's a 1, 2, because I want that double bond to have the lowest number. 3, 4, 5, 6. So I have a hex 2-ene. The double bond starts on carbon 2 and then goes this way. And the branch is a single carbon branch on carbon 5. So that's a 5-methyl hex 2-ene. All right, that's it for the alkenes. Hopefully that makes sense. If you're having any trouble at all, make sure you let me know.